I'm Arlene Sanchez, she's Sarah Dominguez, and this is our PBL.
We will be going ahead and seeing the effects that a base or an acid will have on changing a color of, well, our sponge. Our color indicator sponge, to be exact, actually.
Yes. We're going to be using hydrochloric acid for our acid and sodium hydroxide for our base.
In addition, we have our red food dye and our blue food dye.
Yes.
And lastly, we have the tongs. And the graduated cylinders are just for us to get an accurate measurement.
Yes.
So let's start this off, shall we?
We're going to apply 50 milliliters of hydrochloric acid solution.
A little bit more. All right.
There we go.
And we're going to put it into one beaker.
And we're going to fill it with 3/4 tap water. Up to 500 milliliters.
Beautiful gas, using them and gas.
Oh, thank you.
All right. It's filled with water now. So we got that. Now we're going to go ahead and get the red food coloring, and we're going to change it until it's like a really dark red in color. So Marlene, can you go ahead and lower the screen so the people out there can see? Haha, there we go.
We need an audience.
We need an audience. They could just be assuming that we're doing nothing. Now let's do this. Deep red in color, so dark.
While you guys are doing that, I'm going to fill this for you, okay? 50 milliliters.
Do you think this is a deep red?
A little bit more.
A little bit more.
I think that's enough.
Alright, look at our gorgeous red color. Yes. And now, here, it's time for our other solution. We're going to be using the, I do believe,
Sodium hydroxide.
the sodium hydroxide solution. I'm going to go ahead and put the lid back on this thing. We don't want to spill this. Which we have right here. Again, it'll be 50 milliliters. So we're going to go ahead and pour this.
Now I'll go ahead and fill it with water. There we go.
Which we now got. And now we're going to do the same thing to make this thing a deep blue in color. So do you want to do it? Make this a gorgeous blue.
Blue actually looks pretty nice when it's clear.
Definitely.
Oh, it looks so pretty just going down the thing. Let me get it to the acid solution first.
Just waiting till we can actually see the color, and it's still not turning. There's still a lot of light blue in there. It's more like floating and slowly descending. And I think it's good enough.
Alrighty then.
Yeah, compared to the red, it's not that dark. Let's add some more red to even it out.
But the red looks pretty.
There we go.
Alrighty, now we're going to get our gorgeous sponge out. See, it's already red though. And we're going to go ahead and put it halfway into the acid solution, which is our red. And let's go ahead and do this. Gonna slowly put it in now. Slowly put it in.
I'll squeeze it up for you guys so you don't have dye in it.
Yep.
You did the other half.
Just gonna go ahead and leave that there for a little while.
So it's in.
going to be going ahead and completely submerging it now into the red. So just going to go ahead and completely submerge it. Submerge it. Now. Kind of looks like it's drowning. And it's causing little bubbles. Marlene is going to go ahead and write this observation down so far of what we have done so that we know how it's going here. Going to go ahead and use this thing to now pull it out, and it's in, whoa, it's almost black. It's amazing. Looks kind of creepy, actually. It is almost Halloween by the time we're doing this, though, so I'm going to go ahead and work my way out to get this thing out. Okay, this is backfiring. Safety first, right? As you can definitely see, it is a very interesting black color.
And you have to squeeze out the acid.
Yep, don't want acid in our sponge. Are we supposed to take baths? Oh, she didn't get my joke. Alright. Still got some acid in this thing. Sorry that this is taking a while, I just really don't want to touch it. This stuff is bad for you. Don't get it. Okay, I touched it. Might as well. It's like turned a gorgeous black. Like, not as black as that one thing that they just discovered. I forgot what it's called, but it's supposed to be so black that you can't even recognize it.
Also use your glove hands, Sarah. Yeah.
I'm doing that. Just gonna go ahead and just take the plunge. Ah, okay, here we go. Oh yes, I'm squeezing its life out. And as you can see in comparison to how the sponge looked at the beginning of the video, well, it's puffy because it got all the liquid inside. But it's also, instead of a kind of light red, it's black. Like, seriously black. Amazing, isn't it? The power of science.
Kind of like a deep blue.
There we go.
And it's black. Actually, it looks kind of blue, to be honest.
Looks like a really, really deep blue.
Like, seriously blue. Like, comparison? You can't tell on the video, but it's like a few shades darker than this guy over here. So we got that going for us, which is great. And I gotta adjust my goggles, I'm sorry.
Now you dip it in the other sponge.
That could have been disastrous.
That was very
Now that we're going to be using this blue-black sponge, or are we putting into
your sodium hydroxide.
the base? I'm sorry. Just, alright, here you go. Marlene, care to do this time? Because I took it away the other time? Alright.
So, halfway.
Oh my gosh!
Well, it's quite obviously turning red from our perspective, and
You'll
then-
see it soon enough, but wow, it's really cool. It says to completely submerge it now.
completely submerged.
Yep, get it.
Oh my dear friend.
Get it in there, bro.
Well, we can get it out now. Our
Oh my
beautiful
gosh,
red
look at that.
sponge.
It's yours.
Look how cool that is. Like, wow.
Oh, you did the dye to show it.
It's back to red.
Did the opposite of what it was, supposed to. What color you would have expected.
Well, I guess primary colors can be created in some way.
Yep, I'm gonna go ahead and squeeze it. And see, it's still giving out blue. Or it's kind of brown now, actually, but
Probably makes
you get the point. Look at that. It's like magic, but with science. Gotta keep squeezing it, Just get everything out. Yep. Wait. Yep. Meh.
Okay, Sarah. You
Yeah.
guys can stop the recording.
Mwahaha. Okay. We're gonna go ahead and stop it right here, but here it is.
The ELA connection involves how, if pH has an impact on the properties of dye, it should have an impact on the properties of food. This is because in cooking, chemical reactions occur, and with the multiple different ingredients, different levels of pH are created. As such, we wrote a crash document explaining how this works and why. For our social studies connection, we talked about how the discovery and understanding of pH levels has impacted our society today. This is because pH impacts everything from medicine, agriculture, biology, chemistry, oceanography, forestry, food science, and so many more. If pH affects our field of study, it should affect what we can or can't do.